All right, we're good to go? Cool. Welcome, everyone. This is CTD206. And today we're going to be talking about monetizing your video using server-side ad insertion with AWS Elemental Media Tailor. And specifically, we will walk through a customer use case, Fubo TV, which is a digital live linear streaming service that's using Media Tailor today. And I'm Alex Zhang. I'm the product manager for this service that was just launched at reInvent 2 days ago. And Sung, who we will bring up shortly during the presentation, is the CTO for Fubo TV. All right. So just a quick agenda level set for the session. We'll be talking about video monetization landscape today. And that's just to set the context for what ad insertion is and how we've evolved during the history of ad insertion. Just because ad insertion is a relatively specialized space, we wanted to make sure everyone has the right context for it. We'll talk a bit about what server-side ad insertion specifically is, what Media Tailor does to enable server-side ad insertion, and sort of how you can employ this new technology in your workflow to make a better video monetization decision. And we'll have Fubo come up and talk through their architecture and how they're using Media Tailor. And finally, we'll wrap everything up. All right, so this is a sort of super quick run-through history of video monetization. We started with, back in the day with broadcast TV. And broadcast TV is, of course, a mass market medium. Being a mass market medium, targeting and attribution and reporting is limited. And the best targeting that could be done on this kind of medium was age-gender proxies set by Nielsen gross rating points data. So you had those Nielsen boxes and select US homes that make a statistical inference on what age viewers are viewing your content and what gender those viewers are viewing your content. And then ad providers buy impressions based on what Nielsen statistical analysis says. So that's where we were. With the advent of OTT and sort of internet-enabled streaming for both VOD and live content, we had the ability to really marry first-party publisher data on how your clients are interacting with your content with third-party behavioral and contextual data that has to do with how viewers shop for content, how viewers think about content, as well as detailed viewability metrics, as well as how viewers just engage with ads in general. And beyond that, we now have the ability to insert ads that are beyond just linear ads, linear in-stream ads, but also non-linear ads and companion ads and banner ads overlaid on top of video. And even though OTT enabled all of this, the OTT space is still very, video inventory specifically is still scarce, especially premium video inventory. Just as an example, the sort of dichotomy between how much money you can make from premium video advertising versus non-premium user-generated video advertising is huge. Someone like Hulu, major US streaming service, can charge $35 per 1,000 ad impressions on average. Someone like YouTube, with their video publishers, individual streamers, charge $2 per 1,000 ad impressions. So the variance is huge. But so even though client-side ad insertion, specifically through OTT, allowed the democratization of video monetization for customers, there's a few sort of very apparent downsides to this process. The first and probably most obvious one is for video distribution on the internet today, you want to target a whole variety of devices. You have different Android XO player versions. You have different iOS native player versions. You have HTML5 players on various browsers. You have Chromecast, Roku, Apple TV, a whole fragmentation ecosystem of devices. For example, I've worked with a video provider today that has over 600 different devices that they need to target just for a simple streaming service. So what that means is that in order to enable client-side ad insertion, you need per platform and per device changes on each of those devices that you want to monetize. And that's because client-side ad insertion is done through an SDK or a library that someone like DFP or Freewheel or some other ad server provides you. And depending on your device footprint, that could be complex. The other downsides are with client-side ad insertion, it involves real-time coordination between the playback client and ad servers. And in that real-time coordination, there could be multiple round trips and different intermediaries between. You could have what's known as demand-side platforms, supply-side platforms, ad exchanges, and various other ad networks and different ad systems between when a viewer makes a request for an ad and when the viewer finally sees that ad. And in addition to that, the ad that's returned from the ad server could frequently be formatted in a different way than what the content is formatted in. So that's why, as a customer, as an end viewer, you frequently see a jarring experience between content and ad transitions. You see an aspect ratio change in the video player, you see resolution change, you see a bitrate change, all things that are very disjointed. And that's particularly exacerbated in live streaming scenarios, because live streaming is obviously super latency sensitive, and when you have all these network calls trying to fetch video assets in real time, that could create more buffering and more disjointed user experience. And what that ultimately translates to is people installing ad blockers. Recent consumer research said 64% of customers install ad blockers because of that disjointed viewer experience. And that's particularly apparent on desktop and mobile web. Ad blockers work by blocking a network endpoint. So they just maintain a blacklist on known ad-serving domains like DFP and Freewheel and so on. And as a result, you don't get to monetize any of those impressions viewed on those platforms. So those are the downsides for client-side ad insertion. So which brings us to sort of the next phase of OTT advertising, which is really server-side ad insertion. So server-side ad insertion tries to make the best of both worlds, really taking broadcast quality for video and ads and combining that with a unified view of a manifest that can be created on server-side. So in HLS streaming, I'm sure many of you are familiar with. If not, HLS streaming basically involves a manifest file, and that's essentially a text file that has references to specific video segments. Those video segments can be either a content segment or an ad segment. But in server-side ad insertion, we combine that manifest file to make references to both content segments and ad segments. In client-side ad insertion, you just have a manifest file with content segments, and the SDK makes a call out on top of those, on top of your stream, in order to invoke ad objects that then get inserted into the stream. So it's the difference between server-side and client-side ad insertion in that case is server-side ad insertion unifies the content and ad segments in one manifest file. Client-side ad insertion has a separate process doing it. And just going into a bit more detail on server-side ad insertion, it's really a combination of manifest manipulation, so manipulating that HLS manifest, coordinating all the ad calls, talking to ad servers, which then talk to demand-side platforms, supply-side platforms, ad exchanges, ad networks on the server side, doing on-the-fly transcoding for ad segments to make sure that they're formatted in the same quality as your content, so that when you make the transition as a viewer between content and ads, you don't have that disjointed viewer experience between aspect ratio and resolution changes. And finally, being able to accurately report on ad metrics that is being played back by your clients. So of course, as a service like this, it's hard to do well because with client-side ad insertion, you are relying essentially on distributed clients to scale out ad insertion. Like each individual client has an SDK that makes a call out to DFP or Freewheel or some other ad server and handles the ad insertion themselves. But with server-side ad insertion, every single client is talking to a server, and that server has to be able to construct a personalized manifest that contains personalized ads. It could be, each viewer could have the same ad or could have different ads, but the crux of it is that each viewer's call to the service is evaluated on an on-the-fly basis. So those manifests are personally constructed on the fly, and as a result, they're not cacheable. It's also hard to do well because reporting is relatively complicated. You have a server that's trying to understand exactly what the client is doing with ad metrics. Like, has the client started an ad? How long during the ad have they watched? Have they ended the ad? And finally, there's lots of different standards out there. With videos, there's lots of different standards. With advertising, there's lots of different standards. There's VAST, there's VPaid, there's VMAP. So just a quick, I talked about manifests briefly before, but just a quick reference to what those manifests look like. So in the HLS spec, HLS spec is published by Apple, and essentially is the primary format with which most devices are consuming content on the internet today. One of the later versions of the spec calls for a new, what's called a tag, called discontinuity tags. And these discontinuity tags essentially indicate when content transitions, one segment of video is different from another segment of video. So in this world, the segment that's a content segment is different from the ad segment that's going to come up next. So just to crystallize that, this is what a typical HLS manifest looks like without ads. Just say you're watching content from some live streaming or video on demand streaming service. You have individual segments that are 4 seconds long, which is what the Inf 4.0 means, served from CloudFront. As your player plays through those segments, it downloads them and renders them to the player. Now, if you insert ads, you have the first segment that's 3 seconds long. There is a splice point where there's an insertion at that point. We create a discontinuity marker, and now we have 12 seconds and change worth of ads in the next few segments before finally creating another splice point and then returning back to content. So at its core, what server-side ad insertion is manipulating this manifest file. This is the HLS manifest file that now includes content and ad segments. And that's really one of the motivations for why we built out Media Tailor. It's really, our mission is to allow customers to be able to more effectively monetize their video content on the internet today. And how we do that is primarily through manifest manipulation by constructing that manifest that you just saw on the server side that makes references to both content segments and ad segments without you having to deploy SDKs or libraries on each platform and each client that you want to support. So as a result, you vastly simplify your pace of development and vastly simplify your workflow in monetizing the potentially 600 plus different clients you have to support. Your ads are also better monetized because as a result, we get around ad blockers because manifests are now, again, streamed from one endpoint from the server side. You don't have to go to a separate endpoint like a known ad serving domain in order to retrieve ads. If an ad blocker were to block this endpoint, they block content as well, and that's not what ad blockers are meant to do. So as a result, all your platforms that currently have high incidence of ad blockers now have the potential to monetize. And just as an interesting fact, for those of you out there that have different platforms, the ad block rate is very different for desktop and mobile web compared to if you were serving Roku or Chromecast. I know a customer that their device space is 95% HTML5 players on Safari, Chrome, and Firefox, and their ad block rate is something like 60%. Whereas another customer has 20% traffic on web, and their ad block rate as a whole is much lower. It's under 10%. So it really depends on what your device coverage is and what your end viewer coverage is. We do standards-based client and server-side reporting. And I made reference to reporting earlier. Reporting is really important because as a video publisher, you want to prove to your ad providers, you want to prove to Coca-Cola or GM or Johnson & Johnson that your ads that you inserted are actually being viewed by end viewers. And you can do either server-side reporting or client-side reporting using MediaTailor. Server-side reporting uses the Interactive Advertising Bureau's standard for what's known as quartile and impression beaconing. So that beacons out to an ad server that segments are being viewed and specifically downloaded. So it has started, and 25% of the ad has been viewed, 50% has been viewed, 75% has been viewed, and it has been completed. Those are impression beaconing. That tells the ad provider that their ads has been watched. Client-side beaconing, we surface that through a client-side API that players will then have to call in order to figure out exactly where the ad breaks are and make all the reporting decisions from the client side. And that really exposes other reporting metrics that may be interesting, like pause, rewind, somebody skip forward during the ad. Those are all metrics that are available from the client side. Obviously, as a server, we can't really see when someone skips forward during an ad or pauses the ad. And finally, like all AWS services, we're built in a very modular fashion. You don't have to use any specific player, origin, or CDN in order to use our service. And so we're also built, of course, for scale. And specifically on scale, just a peek behind the hood on how we're built. We're on the manifest manipulation side. We use several AWS components to create this architecture. Specifically, we are deployed across multiple availability zones with our manifest manipulation hosts. We have a public-facing ELB that accepts viewer traffic and distributes it across our different EC2 instances. We are a stateless service, so we, as a result, use DynamoDB as our session store to maintain a consistent view of the session state. And that session state is important because we need to keep track of every single player that's connecting to us. So if you have millions of players connecting to us, we have millions of concurrent sessions in that session store. And we are keeping track of exactly where the player is in the playhead, exactly what the origin is telling us, because the origin really provides the canonical view of the world. The origin is saying, hey, here's all the content, and here are all the ad breaks. We are just taking that view from the origin and personalizing it for each client. And it's telling us all the sort of ad break information and time metadata associated with that session. And each of these, we have multiple layers of caching on each of these instances as well in order to minimize sort of the requests that we make to your origin, which is particularly important if your origin is not scaled up. So on the transcoding side, we do on-the-fly transcoding to ensure that your ads are formatted in the same way as content. You don't really have to worry about it. You just point your ad server at us. We will communicate with your ad server, find out what ads are being requested for a specific user, and if it's not ready, we'll transcode it. And the way that we do that is just a peek behind the hood. We have EC2 controllers in a VPC that's only accessible within the private subnet by internal ELBs. We are looking at Dynamo with every call from the client in order to see whether or not a ad creative has been transcoded before. If it has not been transcoded before, we will push our job out to Amazon Elastic Transcoder. And this transcoder, our queue is provisioned to have many parallelizable jobs that can be executed at once. So from there, we start transcoding the ads. And once those transcode jobs are done, we push it out to S3 in a multi-tenant bucket. And from there, we distribute everything through CloudFront for low latency and global distribution. This is just for the ad segments. Content segments, as a customer, you should and usually do bring your own CloudFront distribution or another CDN distribution in order to distribute your content segments out to end users. And finally, reporting. Again, we use Dynamo as our session state store to figure out whether a player session is in an ad break or not. We figure out it is in an ad break. We make a request out to the ad server. The ad server responds back with vast XML. We parse it, find out all the ad creatives that we may or may not have to transcode in the previous slide, and then we find all the reporting information. So all the start impressions, the quartile beacons, the complete beacons, and any sort of pause, rewind events that are necessary for that specific ad. We put that all into Elasticache. And when those reporting events actually happen on the server side, we make a request out to the ad server. So putting that all together and sort of seeing how you could use a server-side ad insertion workflow, this is probably applicable to, I'd say, 90% of all workflows. At its core, there may be different components, but at its core, this is the flow. The first thing starting from the client is you call a get manifest call on media tailor. And get manifest is really just how a video player starts a stream. But if you'll notice, the way that URL is constructed is a hostname, path, your asset, which is hls.m3u8. That's the extension MIME type for HLS streaming. And then there's a bunch of query parameters. Now, those query parameters are sort of the magic behind how targeting is done. On media tailor, there's really two types of query parameters. There's session-level query parameters, and there's player-level query parameters. Session-level query parameters are a list of parameters that we prepare for you ahead of time that you can specify that you want to use. And these are things that we know about the session, whether from HTTP headers, like refer and client IP, remote IP, things that we know from the content, like the break length, like how long your ad length actually is, how long your ad break is, and things like random number generations, which are important for applications like frequency capping on ad servers. And then there's player variables, which are really just whatever you want to send to us are just opaque key value blobs that we will then proxy to the ad server. So you can send things people have sent before are like device IDs, which are important for Roku, Chromecast, and other OTT devices. Page-level properties, there's maybe hashed customer IDs that you can use to send to your ad server. So that's really just anything that's necessary for your targeting environment. So once again, you call that get manifest URL. You've included a bunch of custom player variables like foobar, BASBAM, IDFA, size, plus a bunch of session-level parameters that you can define beforehand in your configuration. And we finally, at the time of the ad break, we will construct out that ad server URL with those substituted variables. So you'll see you'll have those player variables plus substituted session-level variables that we know about. And that request, in theory, will generate a unique vast XML for that user connecting to our service. All right, so we make that request out. We get to an ad server. We pass along headers, x44, and user agent. We get a response back from the ad server. We parse that vast response to see whether or not there are creatives that we've never encountered before, ad creatives specifically. If not, we will then queue up a job in Elastic Transcoder and transcode specifically to the renditions that are similar to your content. So you don't, again, get that discontinuity between, in transition between content and ads. And when that's all said and done, we finally return a personalized HLS manifest file, again with the M3U8 extension, back to your client. That personalized M3U8 file is not cacheable. because again, they're created on a user-by-user basis. But the ad segments and the content segments are all cacheable, and they should be cached through your own configuration on your CDN. And as all of that is happening, a sideband channel is doing reporting. And that reporting can be done through either server-side or client-side reporting. And with Media Tailor, we really offer you the flexibility depending on your use case. And specifically, on server-side reporting, this on the left there, you just see a JSON log on how we do reporting. That we log this message for every time we fire a server-side beacon. The advantage of doing server-side reporting, which you may fit for your use case, is it's super easy to set up. You don't have to worry about it. You just point your player at a service, start streaming. When we see an ad, we'll insert the ad, and then we'll report on your behalf. You don't have to worry about any additional stuff. The disadvantage are, so the way that we do reporting is that anytime there's a player request, we view that as a watch event. We will then, our service will then make a call out to your ad server saying that this event has happened, and we're reporting on this event. But if for whatever reason your player is making multiple requests for the same ad segment, so there could be buffering, bitrate switches that just happen to happen at the ad break. There could be internet weather that's causing this event. You may have the same player making multiple requests to that same ad segment. And as a result, we make duplicate requests out to the ad server. Now, certain ad servers may not like it because they don't like duplication. So that could be an issue. There's ways to get around that by putting a proxy in front to cache the responses. But we can talk more about that if you're interested. But ultimately, the real decision on client-side versus server-side is really whether or not you have specialized beacons that your ad providers want you to beacon on. So specifically, these are going to be pause, rewind events, and viewability metrics, and things like that are only possible from the client side, because only the player knows when somebody has paused the stream or rewinded by 5 seconds and skipped forward by 10 seconds. Those metrics are only possible on the player side, which brings us to client-side reporting. And client-side reporting is available through an API. When you call this API, we respond back with metadata about the ad break. And this metadata includes a bunch of information about when the ad break started, how long it's going to last for, what are all the discrete ads associated with this ad break, and all the discrete URLs and beacon information and reporting information necessary for this ad break. So here, I'm not going to go through the JSON in detail, but essentially, it has all the start times and all the beacon URLs. But really, the advantage of that is that you can then institute, first, advanced playback behavior. So this is particularly prevalent in video-on-demand workflows, where you may have a pre-roll show up at the beginning of a video, and you force the viewer to watch at least 15 seconds of the ad before they can skip, or 5 seconds of an ad before they can skip. Or you have a countdown timer on the top left nav that says the ad is going to last for 2 minutes, and there's a countdown, right? All that information is custom player development, because that's custom UI that you have to build. But as a result, you need all that metadata about how long the ad break is going to last, how far along in the ad break we are, through the sideband API that tells you all that information. Again, that's related to the fact that you may need advanced beacons like pause and fast forward. And the disadvantage is, of course, you need per platform player changes. So that's on reporting, and really that's on sort of how you could build a server-side ad insertion workflow. It really allows you to take advantage of both internet OTT streaming advances, as well as has the potential to really simplify your workflow and target more devices. And to sort of crystallize that concept, I'm going to bring up Sung Ho Choi from Fubo TV. And I'll let him introduce himself and talk a bit more about Fubo TV and what he's doing with Media Tailor.
Is that a clicker?
Yeah, clicker.
Okay. Hi, everyone. So I'm going to be just talking about, as an early customer of MediaTailor, how we saw the integration points and how it solved our problems. Also talk a little bit more about how we handle our manifest files and how we handle the playlist files and where the integration points are with MediaTailor as one of the earlier customers. Before we get into that, those of you who don't know who Fubo TV is, Fubo TV was founded in 2014, but we launched it in January of 2015. Headquartered in New York, we're a small startup that's tackling a very large industry. We're independent. We raised $75 million in funding, and our goal is to bring most sports for least amount of money. And we're helping the cord cutters get all their sports content, whether it's regional sports, national sports, and all the major leagues of NFL, MLB, and what have you, so that you can still continue watching your sports without having to have a television. The problem that we were looking to solve with MediaTailor and server-side ad insertion concept has been around for a long time, but where we were having trouble with was having the right modularity to put it on top of our playlist service. And I'm going to go over a little bit more about the complexity of the playlist service that we need to build, and we're solving similar problem that the MediaTailor is solving, because all of our playlist is also not cached, because we have a need to serve a very unique manifest file for each person. And the reason for that, and I'll walk through the architecture a little bit, is we have our broadcast partners sending us our videos, and what we do is we encode the videos, and we have about 600 linear channels as an input. But what it turns out at the playback side is we have to turn that into about 900 different outputs because of the switching requirements that we have with different regional sports networks, different requirements depending on the particular content that's playing. Maybe the content is blocked on mobile, which makes it so that we have to be able to serve a different alternate content for people that are on mobile devices. If it's blacked out, then we show a slate. So to handle this type of workflow, we have two separate workflows. We have the videos that are coming in, and we pretty much extract the manifest files out of the encoder. And manifest files, like you were hearing, has information about where to find the next segments. And we store that inside our database, and we have our partners send us different schedules, and we're using a standard called 224. SCUDdy 224 describes about, hey, these are the input sources. These are the triggers that you need to act on inside the stream to be able to say, hey, when this program starts at this time, these set of users are allowed to watch in these regions. These set of users are not allowed to watch in these regions. And that's what we also process at the same time. All of those things get bubbled up into our key value store that serves out the manifest file. So when a user requests a video playback, it checks for, hey, where are you? What device are you watching from? And what content are you trying to play? And we merge it all together, and we serve the right content for that person at that particular moment, and we play that back. So we have a fairly complex logic handling how we decide what you can watch at that particular moment. It depends on your current zip code, your home zip code. There's different couch rights and different hotel rights depending on the sports leagues, the device that you're watching on, and the channel that you're trying to watch on. So with all that said, our manifest file, we've already built very complex manifest system, and when we were looking at other server-side ad insertion providers, they had their own concepts of how linear videos were supposed to work. So we had people that had concepts of channels, and they were making us configure each of the channels, and we have 600 input and 900 outputs. So we would have had configured 900 channels in order for them to build out the server-side ad insertion capability, and that is not exactly what we're looking for, and we were kind of looking for a solution, and AWS Elemental team came to us and asking if we were interested in doing a POC, and we were able to kind of drive some of the conversation, so we gladly took that chance. So the way it works with our service on the playlist side and with MediaTailor is we have a super simple integration point. So all of that complex logic that we have on the playlist is actually encapsulated into the playlist that we present to MediaTailor. And MediaTailor acts as a reverse proxy for those playlist files. And so all of our business logic that we had to put into the playlist is nicely encapsulated into our manifest playlist service. And then MediaTailor just sits right in front of that, talks to our ad servers, and we traffic those ads in there, and they do all of the logic that Alex explained earlier about inserting the ads at the right time and being able to make the personalized ad requests, and it becomes a very seamless experience. And he was explaining a little bit about the reverse proxy, and we're using a CDN in front of that does a little bit of logic for deduplication, and also since the service was in alpha, we were trust and verify mode. So we had ways to fall back to our playlist service directly using the reverse proxy, and then the request just comes from the client. So we were able to launch this whole thing. I think they were developing the service, and we were integrating all at the same time, and this was weeks worth of work while the service was getting developed. And the actual integration points were very simple, and we didn't have to involve the team that was working on the playlist service that has a lot of complex business logic already. Just put the service in front of it, and that was a completely separate team that didn't have to know about all the services. And we were live with the service, and we're monetizing the content. And the kind of beautiful thing about doing server-side ad insertion is that the end users don't know that the ads are coming from us, because if in a linear sports live streaming use case, the ad break's already there. We're replacing the ads that would have been a local distribution ad breaks that they would have seen. So we're replacing ads with ads. So the end user, there was actually no changes for them in the user experience. So the main use cases that we have for Media Tailor is for all of our live streams and all of our time-shifted viewing. We're still evaluating the VOD use case. They do support the VOD use case, and we're looking at using them, although we already have a client-side implementation. And it does give us the ability to fall back to server-side if we detect ad blockers. And being a sports streaming service, if you guys have any experience trying to stream sports online, there's not a lot of legal options, and all the non-legal options require you to have ad blocker pretty much. So our user case, and he was talking about ad blocker rate at 60%. Our users, when we did a quick study on it, I think we were close to 80% of our users had ad blockers installed. So this is an important use case that we wanted to make sure allow us to monetize content. We're at a fairly large scale, so at peak, we handle more than 1 million requests per minute of the manifest files. We expect it to grow much more rapidly. And we're able to make a lot of changes to the ad tags. So the way the Midas is built is that they're just passing through these key value pairs by using a mustache-style templates. So this is somewhat familiar workflow for a lot of people that are in the industry already. But we're able to just add a new key value fairly dynamically to the service and pass in new key values depending on the request of our partners and the agencies that require the firm reporting. And it was pretty much a zero configuration from our video services perspective. And the product and engineering team have been extremely helpful in getting things debugged and getting the product up and running and production ready in a very short amount of time. So big kudos to the team. And thank you. Feel free to shoot me an email. I'll be around after the session if you have any specific questions about the service.
Cool. Thank you, Song. So just to wrap everything up, we are a highly scalable and personalized manifest manipulation service on AWS. And we say here very consciously manifest manipulation because right now we're really focused on monetization and server-side ad insertion. But manifest manipulation itself, just changing that HLS output, has many future applications that we are thinking about. And if you have ideas on or use cases for other manifest manipulation things that we could be doing, we're happy to hear them as well. We operate in various AWS regions, and we're always adding new AWS regions. Right now, at launch, we are in IAD and Dub, but very soon we plan to light up more public GA regions. You saw a bit about how we scale. We use native AWS services to scale, and we have ability to do targeting based on the mustache-style tags that Song talked about. We do on-the-fly transcoding. So as a result, your ads are consistent in quality with your content to the point where viewers on Fubo TV aren't able to distinguish local ads that came in the broadcast stream with ads that we dynamically replaced for them on their live feed. As a result, you can reach and monetize more devices. Reaching and monetizing more devices has two implications here. You not only get to reach the 600+ devices that may not have libraries and SDKs, or at least take a lot of time to develop those libraries and SDKs to do client-side ad insertion. And two, you get to enable those devices that have ad blockers or high ad block rate to now have a better monetization potential. You get more impressions and more bang for your buck. And we do standards-based VAST reporting, which is really important in order to make sure that your partners are aware that all the ads that you're saying you're serving are actually being watched. And like all AWS services, we are pay-as-you-go. That requires no upfront commitment. And we integrate with CloudWatch and IAM and various other AWS services. CloudWatch is where we emit our logs. So we have detailed ad metric logs on every single ad server communication, all the VAST tags that are being used, as well as all the beacons that are being used. Because we are conscious of the fact that debugging on server-side ad insertion solutions can be difficult because we are essentially a proxy in front of your player at this point. And traditional ad tech likes to use a Charles proxy or Fiddler or something on your video player in order to trace the network calls. But that's no longer really possible with server-side ad insertion, which is why good logging is critical for this kind of service. And with that, I'd like to conclude the presentation. And thank you, everyone, for coming.